Hi everyone, this video is for lesson 1-4, which is how to measure angles. So during this lesson, we are going to be able to find and compare the measure of different angles. To get started, there's just this very general diagram, and just discussing quickly if we can kind of figure out, are any angles the same size as this angle over here? So if I just kind of take a look, I think it's pretty obvious that this angle G is definitely not the same size, and all of the other angles kind of look to be around the same size as this angle over here. Now, we're not sure, but I'm just kind of like guessing, right? So if I had to verify my answer, how could I do that? How could I make sure that these angles are all the same size? And what would have to be the same? So if angles are the same size, they have to be equal in measure. So the first thing I could maybe do is I could measure the angles. Right? I could use a protractor and I could try to measure the angles. If I didn't have a protractor, honestly, I could probably use some tracing paper. I could trace this angle here, right? And I can almost kind of show you what I mean. Say this is like tracing paper, it actually works quite nicely. Trace over this angle. And then I could bring my piece of tracing paper over and I could say, all right, well, let's turn it. Does it line up? And yeah, it lines up here. Could compare it over here. Does this line up? And yeah, lines up here. And I could keep on doing that until, oh, look, this one does not line up. So B definitely is not the same size, right? So as you can see, there are some ways that we can compare angles without actually knowing the exact angle measure. So it's a little elementary, so to speak, right? We're actually not going to take tracing paper and compare angles. We're going to actually start this lesson by talking about what exactly is an angle. So an angle is actually formed by two rays that have the same endpoint. Now, the rays act as the sides of an angle. Sure, interesting. Angles have sides. Says who? It's true. And the endpoint is the vertex, or like the middle, or like the corner of the angle. So let me just go here. The vertex acts as like the corner, in the middle of the angle. Okay, so we're dealing with rays. Rays that have the same endpoint form an angle. The rays are the sides. The endpoint is the vertex. So take a look over here. Here is an angle. We can name an angle by using these three different methods. Now, first, you can name an angle by using its vertex. So the vertex is the endpoint of a ray, or like the corner of the angle. So if you take a look here, which letter do you think is the vertex? And the vertex here is A. So I'm going to, this is the vertex. So I can name an angle by using its vertex. So one, I use the vertex. I would call this angle A. Now the angle symbol is like the less than sign with then the uppercase A. If I'm handwriting this, sometimes you'll see me do it like this. And I put like a little line through it. It means the same thing. The symbol in front means angle. If I'm using the computer, I use the less than symbol because it gives me about the same thing. Now the next part, it says you can name an angle by using a point on each ray and the vertex. Okay, so I could use my vertex and a point on each of the rays. So let's take a look. Here's a point on one of the rays. Here's a point on the other ray. Here's the vertex. So I need to use three letters. Now the important part, if you use this method here, the vertex must be in the middle. Right? So I like to trace, okay, my three letters, B, A, C. If I trace it, I form the angle. Angle BAC. I could also go from C to A to B. Although it's two different names, it's identifying the same angle. So it's kind of used simultaneously. Last, a number. Now with the number, typically the number isn't there and you need to add the number. So I'm just gonna put a little thing. Usually you put the number. Not often do they give you the number. Sometimes they do, but for our purposes, we're probably going to be adding numbers into diagrams. So I look here, the number goes again in like the corner by the vertex of the angle. So we could also name this angle 1. And that is how you name angles, right? So formed by two rays that share an endpoint. The endpoint's the vertex. Name the angle using the vertex, using the 2 points on the ray with the vertex in the middle, or a number. Now, when dealing with angles, there are areas of an angle, right? So if I look at this angle here, there are two terms, interior and exterior. So the interior of the angle, that's inside, like between the two rays. So the interior is going to be inside between the two rays, right? The exterior is outside. So it's outside of the two rays. So if you take a look here, from here to here, in between, this is the interior. This would be the exterior. Well, there's another ray, it's down here, so this would be the exterior as well. So you have your interior and your exterior. So really, all of this would be the interior, and then all of this is all the exterior in green, right? It's all outside. That's so. Okay, so let's try one. What are two other names for angle 1? So I take a look at angle 1, and guys, I really like this method. I usually, when I'm doing things, I like go to angle 1, and I go, angle 1 is from here to here. Excellent. And then I say, okay, how do I name angles? Well, I use a number, or I could use 2 points on the rays with the vertex, or just the vertex. So let's use 2 points, J and M, and here's the J and K, and the vertex is M. So I would go and I trace J to M, M to K. So one way to name this angle could be angle JMK. Okay, now using those three letters, it's actually quite easy, right? I have JMK, but I could also do KMJ. So this, KMJ. Okay, and there it is. We're going to get into discussing why this can't be called angle M. That's actually on the next page. So let's turn the page and try this. What are two other names for angle KML? All right, so this, let's trace. You want to trace to figure out where that angle is. So let's use blue from K to M to L right here. All right, so two other names. So it already is KML. There's a number here, so we can call this angle 2. We could also call it KML or LMK, so angle LMK. Remember, you absolutely need that angle sign. So without that angle symbol, your answer is not correct. If you want, you could write angle LMK, but you really need that angle symbol. Now, would it be correct to name any of the angles angle M and explain? So let's just start with this. No. Right. We can't call any of these angles angle M. And here's the reason. If I said, oh, hey, look at this diagram. See angle M? You're going to be like, well, what do you mean? Right? And you might say, what do you mean? Because if I said angle M, you might be thinking this angle in blue. You might be thinking this angle in yellow. You may even be thinking this whole angle in green. The problem is, if I say angle M, there are 3 angles with the vertex M. So no, it's not appropriate to say angle M. If there's more than one angle with the same vertex, you cannot use the vertex to name the angle. So your answer is no, and the reason is there are 3 angles with vertex M. Angle M could represent one of the following. It could represent angle JMK, which is marked as angle 1. It could represent angle LMK, which is represented by angle 2. Or it could represent angle JML, which is the entire angle that we have marked in green. Okay, so there's your explanation as to why calling this angle M would not work. Okay, so let's take a look. When we measure angles, generally speaking, we're going to be measuring angles by using degrees. We, in this class, are actually not going to be measuring angles using any tools, so we're not going to be using a protractor. However, we show that we're measuring an angle by putting a lowercase m in front of the angle symbol. So if you take a look down here, this angle is measured at 62 degrees. So here, in words, the measure of angle A is 62. We write this using symbol notation using this here. Notice a little m in front of the angle symbol. So again, the M stands for measure of, and then you have your angle symbol. And that angle symbol absolutely says angle. The measure of angle A is 62. Okay, so when we measure angles, we can classify them. So this angle has a measurement of 62 degrees. That's not how we would classify it. You would classify angles as either acute, right, obtuse, or straight. So if an angle is an acute angle, that means that its measure is between 0 and 90 degrees. So this says that x, the angle, is greater than 0, but less than 90. So it's really between 0 and 90. That means it can't be 0 and it can't be 90. I think of acute angles as like little baby angles. They're pretty cute. A right angle, I like to think of as the perfect angle. That's shown by having a box right here. A right angle is exactly 90 degrees. Then you have your obtuse angle. These are your larger angles. These angles measure between 90 and 180. So again, can't be 90, can't be 180, it's in between. So if it's 90.1, guess what? It's obtuse. If it's 90, it's right. And then finally, we have our straight angle. Straight angles look like straight lines. They're actually formed by opposite rays. So we talked about opposite rays a couple lessons back, right? Two rays that share the same endpoint that go in exactly opposite directions. A straight angle always measures 180 degrees. So right angles and straight angles only have one angle associated with them. Measure it, so to speak. Acute and obtuse. Acute angles are pretty small, between 0 and 90. Obtuse are large, between 90 and 180. Okay, so let's classify these angles as acute, obtuse, right, or straight. And this is just a little diagram to show like where these angles are in terms of here. So we don't need to, I'll just highlight the first one. The first one says that the measure of angle LKN, so L to K to N, here it is 145 degrees. And you can look at the angle, but looking at this number right here, this is definitely an obtuse angle. So we have obtuse for 145. So A is obtuse. B is 55 degrees. Well, 55 fits into which one of these categories? It's between 0 and 90, so that's acute. C, HKN is 180 degrees. Look, HKN goes straight across the bottom. That's a straight angle. And then you have your 90 degrees. 90 degrees is that perfect angle I like to say as, and that's your right angle. And there it is. Okay, so that's just classifying different angles. So now let's take a look at comparing angles. So what could we say about angle G and angle S? So here's G and here's S. And some things you might be thinking are, well, G and F are facing two directions, okay? They don't share a vertex, correct? But then I see this. So this tells me that they both measure 42 degrees. Okay. Well, if they both measure 42 degrees, then they are both equal. They're both acute, right? They're both between 0 and 90. Okay, let's go back to this. They both measure 42 degrees. So that means that they are equal. Think what it means for two things to be equal. They have the same measure, right? If I was 5 feet tall and you were 5 feet tall, we'd be the same height. We'd be equal in height. These angles are both 42 degrees, so they're equal in measure. They're equal to each other. So that brings up this little statement down here. Angles with the same measure aren't just equal. They're also known as congruent angles. This means that if, so let's go back up here, where are my angles that are the same measure? And that would be G and F. So let's go back up here and fill this in. So I'm going to draw a little arrow so you know where we're getting this information from. Take this and bring it down here. So that means if the measure of angle G equals the measure of angle F, then, well, if they're the same measure, they're congruent. So that means angle G would be congruent to angle F. Remember, the congruent symbol is that equal sign with a little squiggly on top. And there we have it. Now, here's what's interesting. If they're congruent, so say we knew that they were congruent first, that means that they're also equal in measure. Just like with segments. Segments that are equal are also congruent, right? So just I'm off up to the side, I'm just going to write those two little review over here. When you see this, that means equal. When you see this, that's congruent. Okay? So if you take a look here, here are two angles, right? And now notice, wait a second. They have the measure of angle A equals the measure of angle B, but there's no numbers. So remember with angles, you can mark that angles are equal or congruent by using little arc marks. So see this little arc here? This little arc here? That tells you that they're equal, which also tells me that they are congruent. So it says here, you can mark angles with arcs to show that they are congruent. So you can put more than one set of arcs on something if you have more than one pair of equal or congruent angles. Okay, let's take a look at this now. Okay, it says we have some synchronized swimmers and they form angles with their bodies shown in the photo below or over here. If the measure of angle GHJ, okay, so GHJ, that's this angle here, is 90, what's the measure of angle KLM? Okay, well, based on this here with the arc marks, they both have two arc marks. So that means that this is 90, then this has to be 92 because they have the same arc marks. So your answer here is just 90. Okay. Now it says if the measure of angle ABC is 49, okay, what's DEF? Or again, this is one arc mark and so is this, so this must be 49 too. So 49. That's how it works. So the arc marks really help you out a lot because if you can recognize that they have the same number of arc marks, then they're equal in measure. All right, moving on. And remember, this is a video, so if I'm going too fast, by all means, pause, rewind, fill in your notes, so on and so forth. Okay, now let's talk about adding angles together with the addition postulate. So take a look at this angle over here, and it says that we have a point and point B. Now, if you notice, point B is in the interior of this angle AOC. So let's fill this in. This right here is in the interior, right? It's on the inside of that angle. If that's the case, then these two smaller angles, this angle here, AOB, and this angle here, BOC, add up to be the entire angle AOC. So we're going to write that down. We're going to write the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. There we have it. Like that. So kind of like segment addition, two small angles can add up to form the entire angle. And you can tell that because once I put the green and the blue together, it forms the entire purple here. All right, so how do we do this? How can we now use the segment addition? And here we have it. If angle RQT, so this entire angle, so really from here all the way to here is 155. Hold on one second. So it's 155. How can I find RQS and TQS? Let's use the angle addition postulate. The angle addition postulate says, take your two smaller angles, so the measure of angle RQS plus the measure of angle SQT equals the entire angle RQT. Now, this is actually taking the postulate and putting it into like some angles. We can just use the expressions, right? This small angle RQS is 4x minus 20 plus SQT is 3x plus 14. That equals RQT, which is 155. That's the entire angle. And now from here, it's the algebra. Remember, for algebra, you draw your line down the middle. Here it is. Combine like terms. So when I combine my like terms, I get 7x minus 6. And that equals 155 on the other side. Okay, and now you want to get the x alone, so we're going to add 6 to both sides. And then we have that 7x equals, 7x equals 161. And then finally, just divide by 7. And x equals 23. Okay, so that helps us to find the value of x. Now we have to find RQS and TQS. So the measure of angle RQS is the expression for x minus 20, and the measure of angle TQS is 3x plus 14. So I'm just going to take 23 and substitute in. So here we have 4 times 23 minus 20. So we have 92 minus 20, which is 72. And over here we have 3 times 23 plus 14, which is 69 plus 14 is 83. So measure of angle TQS is 83. And here we knew that measure of angle RQS is 72. And there it is. So that's how you use that angle addition postulate. So let's go ahead and try it for this one here. We have a straight angle, DEF, which we know a straight angle is going to sum to 180 degrees. So from here to here, we have 180. And then from this point, we can write our equation, right? We know that the two angles, 11x minus 12 plus 2x plus 10 has to equal to 180. Okay? Like before, draw your line down the middle, combine like terms. For this one, I'm going to kind of cut to the chase, right? We just find that x is 14. After we solve that equation, we isolate and we solve, we get x equals 14. Now, if you have to find the measure of angle, DEC is represented by 11x minus 12. Measure of angle CEF is represented by 2x plus 10. Now just plug in. You have x is 14, so you have 11 times 14 minus 12. So that's going to give you 142. And over here, you have 2 times 14 plus 10, which is going to give you 38. So the measure of angle DEC is 142. And over here, the measure of angle CEF is 38. Okay? And that is how we use the addition postulate for angles. Very similar to the segment addition postulate that we did for segments. That does finish up this lesson for 1-4, dealing with measuring and comparing angles. There are a couple of questions in the back, this lesson check, as well as this fun little riddle. We would suggest that at this point, you do try the answer, you try these questions. We're not going to collect them, but the answers to this is on the answer key under a copy of notes. So if you have any questions with this lesson, please feel free to reach out through email or the Google Classroom.